So, I believe it was last week, it might have been the week before, we talked about what happens when you have parallel lines cut by a transversal, right? We get some special angle relationships, correct? What were some of those angle relationships? Alternate interior angles. What was true about alternate interior angles when we had parallel lines? They were congruent. What else was congruent? Alternate exterior were congruent. Corresponding, right? Okay. And then we had a pair that was supplementary. What were those called?
Corresponding interiors.
Consecutive interior angles or something. Okay? So we learned that if you had parallel lines cut by a transversal, you had these special angles with those relationships, right? Well, today we're going to do the converse of that. We're going to work backwards. We're going to say, okay, you know those special angle relationships, and you can establish those, then you can say you have parallel lines. Okay? Alright, so we're just going to work backwards. Alright, and so the first postulate is the converse of the corresponding angles postulate. And it says that if two lines in a plane are cut by a transversal so that corresponding angles are congruent, then the lines are parallel. So, if I take and I can somehow establish that, let's say, give me a pair of corresponding angles. Which one's a pair of corresponding? 1 and 3? Okay. So, if I can establish that angle 1 is congruent to angle 3, then I could say that A and B are parallel to each other. Okay? And that would work with any pair of corresponding. You could do 2 and 4, 5 and 7, 6 and 8. Okay? So if I can establish that those corresponding angles are congruent, then that makes those lines parallel. Okay? And it's the corresponding angles converse that does this. Okay? The converse is what proves parallel lines. Now, we have a postulate called the parallel postulate. And it says that if given a line and a point not on the line, then there exists exactly one line through the point that is parallel to the given line. Now, that's kind of wordy, but basically, if you have a line and you have a point that's not on it, exactly one line can be drawn through that point so that it is parallel to this other line. Okay? That's basically what it is. A line and a point not on the line, exactly one line can be drawn through that point to be parallel to that other line. Okay, so in addition to the corresponding angles converse, we have 4 other ways that we can prove parallel lines. Okay, and so the next one is the alternate exterior angles converse. And if I can establish that my alternate exterior angles are congruent, then I can say that the lines are parallel. So in this case, if angle 1 is congruent to angle 3, then I can say that P is parallel to Q. And that's the alternate exterior angles converse. Yes?
This is a little off topic, but do you use something similar to the parallel postulate to make it perfect as well? Like if you can draw exactly one line to make it parallel, can you draw exactly one line to make it perpendicular?
Yeah, that would be the protractor postulate probably. Yeah. Okay. The consecutive interior angles converse. Okay, this says that if two lines in a plane are cut by a transversal, so that your consecutive interior angles are supplementary. So if these right here are supplementary, your consecutive interior angles, then that is going to be enough to prove the lines parallel. So if angle 4 and angle 5, angle 4 and angle 5 are supplementary, and P is parallel to Q. Then we have the alternate interior angles converse. Okay? If I can show my alternate interior angles congruent, then I'm going to have parallel lines. Okay? And again, this is the alternate interior angles converse. So, if angle 6 is congruent to angle 8, original theorem. Remember, the alternate interior angles theorem says if the lines are parallel, then the alternate interior angles are congruent. The converse says if the alternate interior angles are congruent, then the lines are parallel. So the converse is what proves parallel lines. We also have the perpendicular transversal converse. And it says that in a plane, if two lines are perpendicular to the same line, then those lines are parallel to each other. So you see how P and R are perpendicular, and Q and R are perpendicular. Both of those lines are perpendicular to R. So if that's the case, then that is enough to prove those lines are parallel. So if P is perpendicular to R and Q is perpendicular to R, then P is parallel to Q. So, 5 ways to prove parallel lines. Okay? 5 ways. If you can show corresponding angles congruent, you've got parallel lines. If you can show alternate exterior angles congruent, you have parallel lines. If you can show alternate interior angles congruent, you have parallel lines. If you can show consecutive interior angles supplementary, you've got parallel lines. And last, if you can show that two lines are perpendicular to the same line, then those two lines are parallel to each other. And again, in each case, you use the converse to prove parallel lines. Okay? So, let's work a couple of problems. Given the following information, is it possible to prove that any of the lines are parallel? If so, state the postular theorem that justifies your answer. Alright, so if I told you that angle 1 and angle 6 were congruent to each other, could you prove any lines parallel?
Yes.
Yes, which lines?
L and N.
L and N. Okay, so L and N would be parallel to each other. And what would my reason be? Right. The alternate exterior angles converse. Alternate exterior angles converse. Good. Alright. Another. Angle 2 congruent to angle 3. Angle 2 congruent to angle 3. Could I prove any parallel lines on that? Yes, what? L and N. So L is parallel to N, and what would my reason for that be? Alternate interior angles converse. Okay, how about 1 and 4? Would that be enough information to prove lines parallel? They're not consecutive because they have to both be inside the line. Are they corresponding? No, because if you think of this like a quadrant, this is like first, second, third, fourth, first, second, third, fourth. This is like in the second, this is like in the third, right? So those aren't corresponding, right? And they're not consecutive interior because they're not both inside. They're not alternate interior because they're not both inside. They're both exterior, but they're not alternate exterior, right? So these are just two random angles that are congruent. So that's not enough to prove parallel lines. So in this case, we would put no parallel lines. And on your, the problems in your homework, mark the congruent angles. Then look at what lines create those angles. Okay, look at what the transversal is and look at what the parallel lines could potentially be. Okay, but mark that. It's going to be important that you mark it. Because sometimes you're going to have, a second line over here. Oh, that's terrible. But anyway, you're going to have a second line over here. You've got to determine if it's these or if it's those. Okay? And so it's important to look at what is creating the angles that you're working, or what lines are creating the angles that you're working. Okay? to find the measure of angle MRQ so that A is parallel to B. So we want A and B to be parallel, right? So what's going to have to be true about these angles in order for that to happen? They have to be congruent. That's what kind of angles are these? They're alternate interior. So my alternate interior angles have to be congruent for these lines to be parallel. So I can set these two equal to each other. 5x plus 7 equals 7x minus 21. And so that ends up being what? 2x equals 28. Divide both sides by 2. And x is going to be 14. Is that my answer? No, look at what they're asking for. Some of you guys messed this up on the test. It's not asking for x in this case. It's asking for the measure of the angle. So I got to go back and plug this in. And so that would be MRQ is this angle right here. So that would be 5 times 14 plus 7. 5 times 14 is 70 plus 7. So it would have to be 77 degrees. Find the measure of angle MRQ. No, it just says, what would the measure of the angle have to be for them to be parallel? And so it's kind of a backwards proof because you're using algebra instead of a two-column proof. But, you know, if you could show that those alternate interior angles are congruent, then the lines would follow suit and be parallel. Okay, last one. Find the value of x so that n is parallel to n. Find the value of x so that n is parallel to n. What kind of information do we have here? They're consecutive interiors. They're both inside on the same side of the transversal, yes? Okay, so what has to be true about these? They have to be supplementary. Okay, so we're going to do 7x minus 2 plus 10 minus 3x equals 180. And so we collect our like terms. That gives me 4x plus 8 equals 180. Subtract 8 from both sides. That gives me, what, 172. And divide both sides by 4. And that gives me 43 for x. Now, do I need the angle in this one, or are we good with just x? We're good with just x. Okay? Alright. So, remember, the theorems and the postulates prove congruent or supplementary angles, right? If the lines are parallel cut by a transversal, then it's regular theorems and postulates prove congruent or supplementary angles. Okay? The converse, we have those relationships. The converse proves parallel lines. Okay, so make sure you address that correctly. Okay. Now, I'm going to pass your worksheet out. And I want us to do, because there's a couple proofs on the back. There's one proof on the front that I want you to do by yourself. You might come back to that one. You might want to go and work these ones on the back first. I'm going to work one of them with you. And I'll work one of them with you, kind of to show you how to get started on this. And I think these proofs are kind of easy. I like these way better than what we did last chapter. Okay. So, looking at number 15. Okay? Now, one thing that you're going to notice in these proofs is that they sometimes take the given in two different places. Okay? And that's okay, because they'll state the first given and everything they can get from that, and then they'll state the second given and everything they can get from it, and then make a connection. Okay? So, in this problem, it says P is parallel to T, right? And Q is parallel to R. So these are parallel, and these are parallel. Okay? Now, P parallel to T, what would my reason for that be? Given. Okay, so if P and T are parallel, then it says that angle 1 and angle 2 are congruent. Okay, now be careful. Is it the converse or is it the alternate exterior angles theorem? It's just the theorem because we're stating congruence of angles, right? So this would be the alternate exterior angles theorem. It wouldn't be the converse. The converse proves parallel lines, okay? All right. Then my third step says Q is parallel to R. What would that be? Given, right? And then from that, these two are parallel. They say that 2 and 3 are congruent. So 2 and 3 are congruent. Not consecutive angles. What would these be? Corresponding angles postulant. I know, it's easy to do. Okay. So, if 1 is congruent to 2, and 2 is congruent to 3, what's going to be true about 1 and 3? They're going to be congruent by what? Huh? If 1's congruent to 2 and 2's congruent to 3, then 1's congruent to 3 by transitive. Okay? Some of these, I'm not going to do this one with you, but like, see here, we're proving parallel lines. So in that step, it's going to be a converse of something probably, right? Because you're proving parallel lines. Okay? All right.